All right, now let's go and get started. Welcome. All right, last time we finished up on talking about the basic command line usage. How's that coming for everyone? Making sense? Yep. Some of y'all probably had some experience with it. Coming along, it's all right.
The home thing tripped me up. Other than that.
Yeah, that was kind of weird because there's an actual home folder.
Yes.
And there's like,
Oh yeah. And then there's the place you started.
Yeah. Yeah, normally where you start should be your home, but not always.
Okay.
Especially in Bash and on Ubuntu under Windows and other locations as well. But yeah, your home is where you should start at home, but that's not always the
if you
case.
just type CD, it'll bring you to this other place. And if you type
CD.
just CD and then just type the command CD and it'll bring you to it's just a tilde.
Yeah, tilde. That should give you to home.
That's your home,
That should be home.
but it's not.
It's not?
It's not the place that you start and it's not the home folder.
No, well, the place you start may not always be home, but
yeah, it's just.
but you should get to home by doing CD tilde. That should put you home. On my machine, like over here, if I were to, I'll go and create a new terminal, to tab there. See, right now I'm not in my home folder, but if I do CD, actually that puts me to my home folder, but so does CD tilde puts me to the same place, home quest, on this machine. And in general, your home folder should be /home/your username. That may not always be the case, depending on the system, but I would say over 90% of the time it is. All right. Any other questions? That was good. Or any comments? Okay. We're going to speed through a couple of this. So Linux philosophy, everything's a file. Directories are files because I just said everything's a file. And a directory is just a file that points to other files. All right, good. Directories. In Windows, you probably always call these folders. I would call them directories because that's what I'm used to calling them. They can, of course, be nested. Hopefully we're all good with that. Keep in mind that since everything's a file, your device is a file. So in this example, the CD-ROM drive is /dev/HDC. But it can be other things as well. Usually your devices are in /dev. Console is the console where you actually do your interaction with the machine. TTY, we talked about that. That was the old teletypewriter, how you used to do input and output with keyboard and a screen. And null. What's special about null?
Put stuff in there, you don't miss it again.
It doesn't come out. It's a black hole.
It's gone.
It's gone. All right. So we started to talk about compilation. Actually, we did go through compilation. GCC, GDB, DDD, make, Valgrind, and GNU plot, which we'll talk about in the next set of slides. And we did go through an example C++ program and compiling it, right? Oh, beautiful. So here's a program. When you compile it, it produces an a.out when you just do GCC test, but if you do -o, you can tell it what executable you want it to produce. If you add -g, it'll add some compiler flags, which we'll talk about in a bit, actually later on in this lecture. -o adds optimizations. In general, you want to do -o or -o2. The only reason not to is if your code's taking forever to compile, which is probably rarely the case, unless you have a huge program. You can get error message, which it's spelled wall, but really it's warning, and then afterwards you tell it which warnings you want it to give, and so you can put all, -warning all, or just wall. So here's a C++ program. And y'all did cout, right? In procedural? Okay. And you can compile multiple C programs into one by just listing them all in the command line. Here you notice I did CC. That is not actually a typo. In general, CC maps to GCC on your machine, but you can also map it to other compilers as well. It's basically an alias. And you can compile files individually to produce .os and then chain them all together at the end. And who remembers the advantage of this?
So you don't have to recompile the entire program, just, like say if you have to fix something,
Right.
in one of the files.
There we go. So you only have to compile one of them. Keep in mind that this is what your IDE is doing in the background. You're just doing it manually now. All right. Hopefully, now we'll start getting to some new parts. Hopefully you can see that's going to get pretty tedious pretty quickly with a lot of different files running around, having to type everything out. And they realized this, so in probably, I think, early 1970s, they immediately came up with a solution called Makefiles. It's really a, it's kind of an inference engine, kind of, so to speak, but it's used to basically automate all these tasks for you, so you can just type make space whatever you want it to do. You can define variables in it and then later on use it in order to produce what you want. So for example, you could have very common ones called C flags. These are usually the flags you want to send to your compiler. Hence -G for debugging and -warning all you want to whenever you're compiling to always use those flags. Source files in case you want to list the source files to compile. We'll go into that. And then CC if you want to change which compiler you are. For this class, we're only going to be using GCC, but do keep in mind that Intel releases the compiler ICC, and there are other compilers out there as well. Popular one now is called CLang or Clang, and that right now is the big battle on open source, whether you use GCC or Clang. We're currently going to stick with GCC for now. All right, let's go and do a quick little example. So class code, compilation, perfect. So this is our old code. Let's go and create a makefile. It's literally called makefile. You first need to start by giving it some type of rule. When in doubt, call it all until you figure it out what you want to do. When you want to define the commands inside of a rule, you must tab it over. One tab. This is just the way makefiles work. You have to use a tab. Don't use space. If you use space, it will not work. You must use a tab. So here we go, G++, let's do -C, and then we'll be hello world.cpp. We'll go ahead and save that. And what do we have, hello world? So I do make, ooh, no such file directory. Did I misspell it? Hello, hello. Ah. Let's use hello, hello. Now if I did make, notice it just ran the command and produced the .o file. All right, well that's not too helpful. Well, that may not seem that great. But what other C files do we have? We had hello and main. So I'm going to go open up the makefile. I'm going to copy and paste. So in VI, the way you do is do YY. That copies a line and then P pastes it. So I did P twice in order to paste it twice. So there's hello and then there's main. So now if I did make, it would actually compile all three of them. Notice it's just running the commands for me.
So you name it makefile and run make.
Yes.
So can you only have one makefile?
You can have multiple makefiles, but your main makefile must be makefile.
Okay.
And when you go and make has evolved a lot since its inception. Good morning. And so you can actually include makefiles from your makefiles if you want to have multiple makefiles to kind of automate certain parts, or like standard C++ where you want to import certain variables. But the main file must be makefile. Okay, so if I were to ls, notice that there's kind of a lot of, the term we usually use is cruft, but it's a lot of extra files we don't need right now. So I'm going to open up the makefile, and another common rule is clean. And I'm going to have this one rm.o and hello. So if I were to save that, notice I'm going to ls. If I do make clean, and then I do an ls, notice make clean just did remove .o and hello and the hello. ls, notice it cleaned up a bunch for me. Good morning. If I were to type make again, it just runs those commands, do an ls, and now the .o files are there. Do you see what it's doing? Yes.
In the rm command, what does the hello do?
So the hello, let me go back to my machine.
Because I understand with the star.o, that just means anything with .o extension.
Yeah, remove everything with .o and remove hello, the file hello. Notice that we had a binary called hello up here, and now it's gone.
So essentially, every space you put is like a comma for another.
Yeah, another thing you want to remove. Good catch. All right. Hopefully you can see that it doesn't actually create the hello, so we probably want to do hello, G++, we'll do hello, hello.o, and then hello.cpp, and then main.o, and then we'll output it to hello. So now I'll save that. If I do make, it compiles everything, and then it spits it out as hello, so now I can run it, and currently the program prints out hello world twice. If I want to clean everything up, I just do make clean, and then notice that it's all cleaned up. Okay. Hopefully you can see this is easier. The one thing I want to make sure you understand is that just typing make by convention, this is just convention that everyone's agreed to, typing make just compiles everything and then produces the binary. That's the default operation of make. You of course can change it to be whatever you want, but in general you want make to just compile everything. That's just by convention. Make clean cleans it all up. Make sure you don't delete your source code files when you do make clean. So in other words, don't do star.cpp. You'll be sad very quickly. Don't accept it, but don't do that. So those are two very common commands right now. All right, y'all see what make's doing right now so far? Yes.
What is that -c?
So that -c is to compile the CPP and produce an object file. Don't produce an actual executable. So this is when you want to compile a specific file. Common thing to do is have that file represent a class, so you want to just compile the class. And then later on, notice that main.cpp actually had the main function that you want to compile. So then you would compile that and compile the main function, compile your two modules, hello, hello, and hello, and then at the end you would link it all together. I don't have time to talk about linking and all that, but, well, we may go into it. But we're just going to use G++ for all these commands just to make our lives easier. Okay. Dependency rules. So this is where things start to become a lot more useful. I'm going to go and come up with another example. Let's see. So we did compilation. Let's go mdir. We'll do makefile1. And so, what would be a good example here? CHR. If y'all have a simple example y'all want to see, please tell me. Oh, good, my battery's fully charged. Let's see, what would be good here? Let's do 7H. All right. So here we could do cout sum of 1 to 100. Obviously that file function doesn't exist, so we'll do include. I'll just do sum.hpp. Oops, yeah, we want to do that. This is just to give you another example to drive home what's going on, because I know all of this is new to y'all. So this program is going to call function sum 1 to 100. And then print off, and then we're done with this program. Okay. I'm going to go ahead and start making the makefile for this. By convention, you want to have all. Right now, we'll just say done, just to give it something. But right now, the other thing is we want to start being able to do different inference rules so that we only compile what it is we want. So it's very common right here to make a rule for main.o that requires main.cpp, and it'll just do g++-c main.cpp. Okay, what does this say? Well, the main.o rule, that's the rule, depends on main.cpp. In other words, if there is any change to main.cpp, you need to rerun this command. But if there is no change, you don't have to do it. How's that helpful?
So it doesn't recompile it?
It doesn't recompile unless it's necessary.
Yeah.
Right. So if you have a large project and you have thousands of CPP files, you don't want to recompile every single one of them unless you have to. So that's what this is already doing. Now we want to have a make all rule, so we'll have a require main.o. If I were to save this and type in make, notice that it did try and compile main.cpp, but look, we have an error because sum.hpp doesn't exist. All right. Have I talked about header files? Okay, good. So we'll go ahead and create sum.hpp. And we'll go ahead and basically define int sum int start int end. And that header file, so if I do an ls, that header file exists. Now if I type make, all right, we're still almost there because cout wasn't defined because it's actually part of the standard template library. So we'll make that little change, make, and now it's actually compiled it. Okay, great. Echo done. Done. Okay. Notice when I typed make again, it didn't recompile main.cpp because there was no change to main.cpp since the last compilation. All right, let's go ahead and create the sum.cpp. So sum.cpp, we'll go ahead and include sum.hpp, and then we'll go ahead and define sum. Anyone remember the formula? Oh, we'll do it the long way. Sure. Ooh. I need to fix that. I equals 0, I is less than, actually I will start at start. I is less than or equal to end, I plus plus. We'll have sum plus equals I, but we haven't defined sum yet, but that's all right. Return sum. There we go. Okay. So we have a little quick function right there. Just adds each individual integer from start to end and then returns the sum. Might be some errors with this code, but that's all right. We're just trying to do an example. How would I edit my make file to integrate the sum.cpp into it? All right, so I'm just going to copy this command, sum.o, sum, like that. All right, anything else I gotta do?
Put it in the hole.
Yeah, there we go. So that it knows to actually compile it. And now let's go ahead and actually put it all together. Main.o, sum.o, and then we'll have it go out to sum. Okay, so I'm going to type make. Which commands should it actually compile or run?
It should only run some because that's the only one you made changes.
Right, it'll run some, but it is also going to run all because that's what we're telling it to run. So then it'll compile and put it together. All right, and if there are no errors, there were errors. Oh yeah, look at that, classic. Forgot the semicolon. There we go. Hey, look at that. If I were to type make again, what command will it run?
Just the hole.
Right, so just the g++ main.o sum.o output to sum. Okay. Let me open up sum.cpp. Let me add a new line right there. if I type make, what's going to happen?
It's going to run the sum compilation and all.
Yeah. So notice it recompiled sum for us.
Good question.
Yeah.
On that bottom line, what you have in the all, when you have two, you have both main.o and sum.o, and then you name it sum. What exactly how does that combine them into? What exactly does that do?
Okay. So main.o and sum.o are the object files, the compiled versions of those two CPP files, okay? So when you pass those to G++, it's going to link that together, and then it's going to produce an executable. The -o, I'm telling you what the file name of that executable should be. -o output, so output that executable to the file sum. Now I could have called it sum.exe, and those of you coming from the Windows world, that might make a little more sense. So now, and then I can do sum.exe, same thing. Remember, Linux doesn't care about file extensions. Is that clear?
Yes.
You are free to call it .exe if that helps you. You're not going to have any points taken off for that. I will probably not use .exe because that's just not what I use. But it could be either one. Now in a makefile, it is good to do a full clean. So we'll do clean, rm o sum, and then sum.exe. So we'll go ahead and clean that. Do an ls. Oops. Oh, I didn't do make clean. Now we're clean, then we can do make. Recompiles it all because remember those files didn't exist, and then it produced the sum.exe. Now if I do make clean, it should give me an error. Yeah, because sum no longer exists. So we'll take that out of the list. Make clean. There we go. And then I can make it again, and now we're back. All right. Hopefully you see with a little bit of extra typing make is going to make your life easier. Does that make sense?
So should you always, like, after you use a make file, should you delete the contents of it and use it? That's what I'm confused about, like, because it's named make file.
Right.
So there's only one that can be named make file.
Right. There can only be one.
So after you use it for a project, should we clear it out and then use it again for the next project, or just?
You can copy it over for another project if that's what you're asking. You're going to use. I feel like I'm not answering it the right way. In general, you're going to make a new directory for every project. So you just make a new make file in that directory.
Okay, that makes sense.
Yeah. All right. Because the make file is specific to the current directory you're in. Because when you call make, it's going to search the current directory for a file named makefile.
Yeah. That makes sense.
Yes. Yeah. Doug, good question. There is no master makefile for every project. Yeah, that'd be bad. All right. Oh yeah, and you can add comments to makefiles by using the pound. This is a comment. And it just ignores it. Okay. All right, so this is another example. Let's go ahead. I typed one out for class today. Let's see if we can read this and figure out what it's doing. The top thing is creating a variable called GCC. This is a variable inside of make. I'm sorry, it's creating a variable called CC. The variable's name is 2 capital C's. So we're going to GCC. All is going to depend on main. So we got main down here. So what's happening is, if you just type make without saying anything, it's going to run the first rule, which happens to be all, which depends on main. It's going to jump over main, which is going to say, oh, we need to create main.o, which jumps back up to main.o, which then detects if main.c has been changed. If it has been changed, it's going to run this command, cc, which has happened to be GCC, so gcc-g-wordall.compile main.c. Is everyone following me here? All right. Then it backs out, says, okay, we're done with that rule. Let's go ahead and link it together. GCC with debug flags, main.o, produce the main executable. Notice in this one there's only one C file.
Is that a typo with?
Yeah, with the dollar sign.
Yeah.
Right here?
Yeah.
Oh, yeah, look at that. Yeah, the dollar sign should be on that side.
Okay.
Thanks. And then it goes back to all, and we're done. And back to clean. One other rule I wanted to help you that probably would be helpful. We'll do make run. This is one of my favorite rules. It will depend on all, and then it just runs the executable. So you can type in make run, and it'll try and compile everything and then run your program. So this is essentially clicking the play button in your IDE is the idea.
So can you put like run into the all command as well?
Yeah, so if you wanted to, remember it's just running the first command. So if I were to take this and put it up top and then type in make, it runs the first rule. When you type in make, the thing it's going to run by default is the first rule. I can do make clean, make, compiles everything, links it together, then runs it. What's important about make is that if there is an error somewhere, it's going to stop. It's not going to try and run your program, try and link it together or anything. Once it encounters an error from a program, it's going to stop. Because all programs will give back whether they succeeded or failed. All right, so you probably want this one, don't you? Just type in make and life is good.
Yeah.
That's all I want in life. All right, and then if you want to run clean, you can just remove it. Okay, we did this example with multiple files. Notice here all requires, looks like prog. Prog requires main.o, file.o, and file2.o. So if I type in make, let's do this just to make sure we're clear on how make files work. If I typed in make, what's going to happen?
Run all first.
To run all, well, it goes, looks at all, and what does it see?
C's problem.
It depends on prog.
Yeah.
So then what is it going to do?
If it changes anywhere in prog, it's gonna run. Well, it's gonna be.
Prog is a rule of makefile. So it's going to jump to the prog rule. Now what does the prog rule say?
Main.o, file1.o, file2.o.
And what does that mean? If
It's dependent on the object files.
it depends on those object files. Now here's where it's a little tricky because it depends on those object files, but there's a rule for that object file, so it's actually going to jump to the rule. So the first thing it'll probably jump to is main.o. And what does main.o say?
Main.c.
Main.c is not a rule, so it's a file. And it's going to say if there's any change to main.c, file 1.h, file 2.h, what is it going to do? If there's no changes to those files, it doesn't do anything. All right. So I helped you out there. What happens next?
Goes to file1.o,
There we go. File 1.o. And what's file 1.o say?
file1.c, file1.h. If there are any changes, then we compile those.
All right.
Then go back to file2.o. If there are any changes to file2.o, it'll recompile.
Okay.
And then it goes back to prog.
Right.
And then it recompiles it if there are any changes in all the files. Right? There's one change in all of it's got to
And
be.
any of them, it redoes the whole thing.
Yeah. And then it's done.
It's done. Okay. Any questions about this? Did that light just randomly turn on?
Yeah. Is it motion detect?
I don't think we have motion detector. Did something go in?
I didn't hear the door shut. You don't know like this door moves, but.
Huh. All right. If I were to type in make space clean, yeah, what happens?
Cleans out main.o, file1.o, file2.o.
All right. If I were to type main or make space main.o, what happens?
Space main.o. We just make Oh, we make main.c, or we compile main.c, file 1.h, and file 2.h.
If I typed in main.o, it would just try and compile the main.c, assuming those files. But it's only going to do that part. So you can actually do each individual part by passing it to make. All right. Commands can be anything. Literally, make is just taking whatever command you have and running it at the command line. So it doesn't have to be G, C, G++. You could use this tool to make anything or any combination of things you want to. And this will become very useful once we start learning about Valgrind, hey look, Valgrind's as well as GNU plot. It'll make your life a lot easier because you just have to type in the command once and then move on from there. All right, I'm going to talk about a couple of advanced features of Makefile. We are not going to be using these in this course, but if you start messing around with Linux, at some point you're going to be having to use these, so I'm going to at least cover them from a high level, and then you'll know what you need to look up. Make param, basically your parameters. Clean deletes, make runs the dependencies for your program. Really, it just compiles all the dependencies you need for a program. When you install a program, notice you have a lot of shared libraries, so sometimes you need to go in and actually compile those. This is in case you have a full program you're trying to compile. We're not going to go into that because we're just writing programs for data structures, not C or World of Warcraft or something. I don't know why I just went straight to games.
We were talking earlier.
We were talking about games earlier. Yeah, you could also do a web server, same thing. Make clean deletes files created by make. That's what the rules should do. Now there are tools to automatically generate these make files for you. Isn't that nice? So it generates all your dependencies. So not just maybe some shared libraries, but we'll also figure out if you have an O file, what C files need to be in that heading list and what H files need to be. So it's actually going to generate the make file for you. And usually type in make depend. Do you want to learn this one? You can. But right now, it's just typing it out just so you get used to make. And most of the programs we run, it's not going to be that complicated, and I'm actually going to eventually give you a template where it's going to be pretty simple. All right, configure is not part of make. It's a separate program. Well, make depend is not part of make either. But it's part of what's called the auto configuration GNU system. It makes files. Okay. Anything's like make depend, except for this one really goes out and pulls every single source you need and generates a full make file. Make depend just did it for certain dependencies. Again, not needed for this class. All right. So that was a brief run through of make files. Any questions? Comments? No questions? All right. Let me go ahead and stop. Ooh, that was a misspelling of programs. Wow, did I not spell?